Hi guys, Mr. J here. Welcome back to Chem Talks. Today we are going to continue talking about ionic bonding. And we're going to go into our third groups, and this is what we call the variable charge ions, which we find in our transition elements. So let's go ahead and take a look at those. Okay. Remember, our transition elements, these are in our middle. We've already talked about a couple elements that are in there. For example, silver, we know it always has a +1 charge. Remember, we said we can remember it because it's in column 1B. It has nothing to do with it, but it's just a good way to remember it. And the other one we know in there is zinc, which is in 2B, has a +2 charge. It has nothing to do with it, but it's a good way to remember those. Okay, we already talked about these. The trick comes in then with the rest of the transition elements. We're talking the D block elements. Okay. And right there's our D block, and a few of them to the right here, which would fall under the P blocks as well. The problem with these is they're more challenging. We can't use the same rules as we did with our elements in S and P by just looking at is it easier to gain or lose electrons. Instead, we have to use a little math to kind of figure out what their charge is. We could memorize them, but there's a bunch of them. It's easier just to do some reasoning and a little math to figure out their charges. So the problem we find with these transition elements is many of them can have more than one charge. Okay, some may have 3 or 4 charges. And so when we go to write their name, we must indicate what form of that we're talking about or what charge we're doing. So there are 2 systems that we use for it. The one that we're going to be learning about and using is what we call the stock system, and the other system is the classical system. And I'll make you aware of the classical system, but we won't test on it. But it's important to know it because when you go into a chemical stock, you see both systems being used. So most chemical companies are moving over to the stock system. All right. So in the stock system, we're going to use Roman numerals to indicate the charge of that particular atom. Okay. So we're going to put the name of the atom, or the ion, excuse me, and then write a Roman numeral to give its charge. For example, we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you do need to know your Roman numerals to be able to do this. So let's look at a couple examples here. If we have iron 2 oxide, the 2 is going to refer back to the iron, which means that we have a +2 charge. Iron 3 oxide, the 3 refers back to the iron once again. Okay. And it's a +3 charge. Sometimes you'll see these Roman numerals in parentheses, sometimes not. I don't care which way you do. Copper 1 chloride, that indicates we have a copper with a +1 charge. Cobalt 3, the cobalt has a +3 charge. Cobalt can also have a +2 charge. Okay. Once we know the charge, then we can just go ahead and use our crisscross method to determine the overall chemical formula for that compound. But we got to indicate. We just can't say iron oxide. We don't know, is it iron 2 or is it iron 3? So we use that Roman numeral to indicate what charge is. Okay, so let's try this one. If we have nickel 3 oxide, let's write the formula for that. Well, this tells us that nickel is a +3 charge. Oxide is oxygen. We know that's one from the P block is a -2 charge. So once we write it that way, we can simply do our crisscross and end up with Ni2O3. I actually really like doing these because I don't have to think about what's my charge of my cation. It gives it to me right there, and that was a 3. Okay, try this one on your own. Lead 4 sulfide. Go ahead and crisscross, write your charges, crisscross them. Okay, so lead's going to be a +4. Sulfur we know is a -2. Okay, when we crisscross, we get Pb2S4. Remember, we always want to use the empirical formula at the lowest ratio, so we have to reduce each of those by 2, so we end up with Pbs2. Don't forget to do that. Okay, so writing the formulas is fairly easy because they give us, the name tells us the charge of your cation. Then we just got to go our normal rules for the anion. Okay, try these 4 on your own here. Go ahead and pause the video and then come back and we will test and see how you did. Did you pause it or are you just waiting for me to give you the answer? Pause, stop, practice. Okay, it's the only way to get better. All right, so let's look at this. First one, manganese 3 phosphide. That means manganese has a plus 3 charge. Phosphide, if we look it up, has a minus 3. Like charges cancel, so we just have MnP. Tin 4 nitrate, that means tin is a plus 4. Nitrate, if we look at the triad, is nitrogen, minus 3. So crisscross, we got SN3N4. Okay. Copper 2 oxide, copper is a plus 2, oxygen's a minus 2, so they cancel out, CuO. And then finally, iron 3, that means iron, plus 3. Fluoride is a minus 1, so if we crisscross, we get FeF3. Okay, so pretty easy to do these because they give you the charge right in the name. It makes it a lot easier. You don't even have to look at the periodic table for your cation. They give it to you. Okay, let's talk about the classical system. Like I said, I'm not going to test you on this other than excuse me, knowing how it differs from the stock system. And what they do in the classical system, they're going to use suffixes, that's endings added to the end of your cation, to indicate the charge of that particular atom. So with the classical system, you really actually kind of need to know the possible charges of them. Okay, so if let's take copper, for example. Copper has a plus 1 and a plus 2 charge. If it's the higher plus 2 charge, we're going to add IC to the end of the name. Or if it's the lower charge, we're going to add OUS. So if we use cobalt, okay, its higher charge is going to be cobaltic, okay, but it's plus 3. If it's a plus 2 for cobalt, we're going to change it to cobaltus. The way I remember this, which is silly, think of your pantry at home, okay? The stuff that's for us that mom wants to eat, she puts low. The stuff for us is low, so lower charge is us. The icky stuff that we shouldn't eat is on the higher shelves. Okay, mom puts the icky stuff up high, so ick is a higher charge. The stuff for us goes down low, the lower charge. Okay, so for several elements, we go back to the original Latin or Greek name for them, which is makes it, if you know those, makes the elemental symbol make sense. For example, for copper, we go back to cuprum, so it's cupric or cuprous. Lead, plumbic or plumbus. Okay, stannum for tin, stannic, stannus. Ferrium, it'd be ferric or ferrous. Now, I'm not going to charge you or test you on these guys, but I just want you to understand that the difference between the classical and the stock system uses Roman numerals. Classical system is a system that uses ic and us suffixes to indicate the charge of them. Okay, a couple examples here. Okay, this is going to be ferrous oxide because it's the lower charge. Okay, versus this is ferric oxide. Another example here, copper, this is going to be copper 1 chloride, so it's cuprous chloride versus cupric chloride for the higher one. Here's a couple other ones. So nickel, bromine, this is actually going to be the lower charge for nickel, so it's nickelus bromide, doesn't sound like somebody's name. And then the higher one be nickelic bromide. Now how do I know if it's the higher charge or lower charge? Well, I have these memorized, okay, as far as what's the two variations of them, but that's what we're going to talk about next. How, if I'm given just a symbol, do I determine what the charge is? So let's look at that. Okay, so how do we write the stock names when given a formula? Okay, so remember our goal of anytime we're making a salt, which is an ionic compound, is that the overall charge of the compound is 0, meaning the challenges of the cation have to balance out the challenges of the anion. Okay, so they must cancel out. And how do we do that? Well, we use subscripts to do that, right? This is why there's more than one compound, because we have to increase the charges to balance out the other side, right? So magnesium, right, is a plus 2. Chlorine is a minus 1, so we need 2 chlorine to get minus 2 to balance out the plus 2 charge of the magnesium. Well, same thing with the variable charge ion. They're trying to get the same thing, okay? So what we end up doing is working backwards a little bit from the formula to determine the charge of the cation. So let's take iron FeCl3, so iron something chloride. So what I'm going to do is start this. First thing I want to do is figure out what's the charge of chlorine, because that's the cation, the anions, remember, are not going to change. They're fixed, they're not variable. So chlorine has a minus 1 charge. So I'm going to take minus 1 times 3, and I get an overall charge of 3. That means from iron to balance out the chlorine, I got to get a +3 charge. So what's my subscript on iron here? Well, it's nothing written, so we know it's a 1. Okay, so 3 divided by 1 equals 3. That means that this iron is iron 3 chloride. Okay, because it has to be a +3 in the iron to balance out the 3 negative charges on chlorine. So we write its name as iron 3 chloride. Let's try another example. COO. So we got cobalt and oxygen. Okay, how do I know cobalt's a variable? It's from the D block and it's not silver or zinc. Okay, that's very important that you recognize that. First of all, we do have a variable. So if we write this, we know that oxygen always has a -2 charge. How many oxygens do we have here? Well, there's nothing written, so we assume there's 1. So the total charge there is 2. I'm going to put it over there. So 2 divided by how many cobalts? Once again, there's nothing written, so we know it's 1. Okay, 2 divided by 1 is 2. So this tells us that I have cobalt 2 oxide. So cobalt 2 oxide there. Okay, try these 4 on your own. Okay, pause it. This is going to take you a little bit of time, and then come back and we'll test them. You really need to do these on your own. This is probably the trickiest part of this whole unit. So try these on your own, and then come back and we'll do them. Done yet? Pause. Do them. I keep telling you that. Listen to me. Okay, so MnCl2. We have manganese 2 chloride. Okay. Here, Au, what's Au? But remember that's gold. And sulfur. Sulfur's a -2. So -2 times 3 is 6. Bring the 6 up here. 6 divided by 2 is 3. So this is going to be gold 3 sulfide. Okay. Oxygen we know is a -2. And there's 1 down here. So 2 times 1 is 2. We have 1 lead. So 2 divided by 1 is 2. So this is lead 2 oxide. And then finally, nickel nitrogen. Nitrogen we know is a -3. We have 1 of them, so 3 times 1 is 3. Bring the 3 up there. We have 1 nickel. 3 divided by 1, once again, is 3. So that's nickel 3 nitride. Okay, we will practice these in class, okay? But it's not that bad once you get the hang of it. So let's do a quick review of salts. Okay, salts, remember, are simply ionic compounds. That means a metal combined with a nonmetal. We've talked about 3 times now. We've talked about binary ionic compound. That's just 1 salt, or 1 metal plus 1 nonmetal. Okay, 2 elements total. We talked about polyatomics. Remember, we have a sheet for that. Most of our polyatomics are negatives. Okay, most of them are anions. We do have 1 cation. That's ammonia. Okay, we recognize polyatomics ions are present because the fact that the chemical formula is going to have 3 or more elements in it. And then finally, what we talked about today was the variable charge ion. We know a compound is going to have a variable charge ion if the cation comes from the D block and it's not silver or zinc. Okay, so the cations from the transition elements. All right, guys, I know this may seem a little tricky, but once you get the hang of it, it's pretty easy. We will do a bunch of practice in class to get you caught up on this. If you have any questions, please stop in and see me, and we'll get you going. Until next time, guys, take care.